Have you ever written a program that suddenly crashes and the only thing you see is a giant error message that makes you question every life decision you've ever made? Yeah, errors happen, not because we are bad programmers, but because real world software deals with unpredictable situations. A file might be missing, internet might disconnect, a user might enter invalid input, and Rust, being the absolute control freak it is, does not allow us to ignore errors. So today, we are going to learn how Rust handles errors safely, powerfully, and without unexpected crashes. Let's dive in. So, what is error handling? In programming, error handling means anticipating and dealing with things that might go wrong instead of letting the program crash. In Rust, error handling ensures that the program doesn't crash unexpectedly. You, the developer, must think about failure cases and bugs get caught at compile time instead of in the production. Rust broadly has two categories of errors. First is the recoverable error type. In this case, when something goes wrong in the program, we can recover from that error by handling it programmatically. Here we use the result enum, which, if you remember, I mentioned it in the previous video as well. The second error type is unrecoverable. As the name says, once the error occurs in the program, we won't be able to continue safely. In these type of cases, we use panic. Panic is Rust's way of saying something is wrong, shut it down now. In the program, we can use panic like this. It stops the program immediately when it is encountered. See here, it says thread main panicked. Using panic everywhere is a bad practice. However, sometimes it's useful. Situations like when you are debugging a program or want to validate some assumptions. Even sometimes you can use this when you know that continuing the program is unsafe. Here we deliberately made the program panic by using this line. However, there can be situations when the program encounters unrecoverable error, so it will panic at runtime. Like in this example, the print statement is syntactically fine. However, mathematically you can't divide any number by 0. So this program will panic at runtime. You can see the error message in the console. These are the situations when developers need to think and anticipate what might go wrong and deal with it in the program. Like in this case, before performing the division, we can check if the denominator is not 0 with the help of control flow like if else. This could be a corrected program where we are checking if the denominator is 0. If yes, we just notify the user rather than abruptly ending the program. Else, we show the result of the division. That's how we deal with unrecoverable error. Now let's look into recoverable ones. We first imported the file struct from file system module in the standard library. Using the open function of file, we are trying to open the data.txt. At the moment, we don't have this file, but that's what we really want here to get the error. This open function returns the result of file. This means that if file exists, it will return the file, else it will return the error. By the way, I'm using the Rust Analyzer extension in VS Code. It shows all the details. It really helps while debugging, especially Rust. Next, we are using the unwrap function to extract the file from the result enum returned by the open function. Unwrap is, you can say, kind of a convenience method for cases where you expect success and want it to crash loudly on failure. Since we don't have this data.txt file yet, we should get the error. Let's run it and see what happens. Firstly, the program panicked at this line because we called the unwrap on the result enum, which returned an error. And the reason is that the system could not find the file. If we need a specific message, if the program panics, then here, instead of unwrap, we can use the expect function with the custom message. We needed to print file missing. If we run, it will still panic. But you can see the message we expected is printed in the console. Now, if I create the file at the location, then run it, it didn't panic and it says file opened successfully. We can anticipate the file may or may not be available. So error can be recovered even if the file is not present by using the result enum. Since this open function returns the result enum, instead of getting the file by unwrapping here, let's get the result itself. We also don't need the print here. Result is an enum, so we can write match file and handle the two possibilities inside the braces. First is if we get the file. Okay, F, then we can print file opened successfully. We are not using the F variable in the print, so we'll prefix the underscore. This will help us to get a clean output in the console. And the other possibility is when we get the error. So ERR E, and we can print failed to open file. Let's print E as well to see what we are getting as the error message. Since we now have the file, after running it, we get file opened successfully printed. Let's delete the file and see the error ones as well. This time, the program didn't panic and printed the message we wrote, failed to open file, and then the error message. So this is how recoverable errors can be handled in the program in a controlled manner. Rust forces us to think about both success and failure, and that's good. We can write this opening the file operation in a separate function as well. We'll create a new function, read. It will return the result enum with either the file itself or error. Error belongs to IO module of standard library. Inside the function, we can just write the operation. I'll copy it here and return the file. In the main, we just need to call the read function. The behavior after running will remain the same. There is also a concept in Rust called error propagation using this operator. Putting the operator at the end of this line means if this operation fails, immediately return the error to whoever called this function. Don't continue the execution in this function any further. In our case, we don't have the data.txt file as of now, so this line will fail. So then instead of executing the next line, which is returning the file, it just returns the error immediately. Say for example, in this read function, we don't want to return the file, but a string value success. If this line fails, it will return the error because of this operator. Else, if the operation succeeds, will return OK, success. It's a literal, so we'll use toString. In the main function, we'll print the message. See, this is the benefit of Rust Analyzer. It is showing this warning at this file variable because it is unused. So we will prefix it with underscore. Now let's run it. We got the error since we don't have the file. Let's create the file and run again. We are getting the string success printed in the console. If we don't use the error propagation, then we had to write the cases using match and then return them individually, like this. But the operator does it all implicitly. We can have multiple lines with the error propagation operator for error chaining. Apart from these error types, we can use enums to denote custom error types as well. Here's a simple example. We have an enum for login error. Either we have an invalid username or an invalid password. Now this function handles the login. It takes username and password as parameters and checks if they are correct. This function returns the result enum. So basically, if the login is successful, we will return nothing, denoted by the unit type. Else it will return the login error enum. First condition is if the user is not admin, then it will return the error with this error enum type. Same thing if the password is wrong. It just returns the error enum of the invalid password. And if everything is matched, it returns the unit type. In the main, this login function is used with admin as username and 1234 as the password, which is expected. This match block prints login successful if everything is okay. And if it encounters error, it prints the enum. We have the derive debug added, so it should print the enum. Now with correct username and password, if I run, it prints login successful. Let's change the password first. Run it again. Now it prints invalid password as expected. Now change the username and run. We get invalid username. Note, both username and password are wrong. But since username is checked first, so error for invalid username is returned. It is also possible to convert standard errors into custom using traits, like this. However, since trait is not covered yet, I won't explain it here. Subscribe so you know when the video for trait is out. If we want, we can conditionally throw the error manually as well. Like here, if we get error, we print the error type. Along with it, we want to stop the program as well. So inside this block, we can write panic, login, failed. Now it panics when it gets the error. Approach of handling errors in Rust is a bit different from other languages. In Java and C#, we have exceptions. Rust has nothing called exceptions. C program returns certain codes, whereas Rust uses typed result. Python handles error using try and except, whereas Rust uses match and error propagation operator to manipulate the error. Do we really need to cover JavaScript? It throws error anywhere, but Rust enforces the handling at compile time. Actually, Rust avoids random exceptions, silent failures, and null pointer crashes. Okay, so what all we have learned about error handling in Rust? Use panic in truly unrecoverable situations. Use result enum for recoverable errors. Error propagation operator helps us propagate the error upwards. And we can utilize enums for certain custom error types. I have to agree that error handling in Rust can feel a bit verbose at first. But this strictness helps us prevent runtime crashes. This actually makes Rust suitable for safety critical systems. In the next video, we'll go even deeper into real-world Rust. So make sure you subscribe because trust me, the journey only gets more exciting from here.